Hi, I'm Christoph Schleifenbaum. I live in Sweden and I work for KDAB. In this video, I will show you how to use Qt's serial bus module to communicate with devices that support the Modbus protocol to access their registers. Modbus is widely used in industry, but even in energy management systems at home. I will use my EV charger to demonstrate how it works. Let's go! Many industrial applications use Modbus when it comes to communication with different controllers. It has become a de facto standard formed at the end of the 1970s and is today used even in home appliances for energy management. The protocol supports communication via serial lines as well as TCP/IP. Today, I will show you how to implement a Modbus client in Qt using QModbusClient. We will also have a short look at how a Modbus server could look like. I want to be able to control charging of my electric vehicle. My charging equipment, a so-called EVSE, offers me to both activate charging and to set the maximum charging current via Modbus over TCP/IP. So I wrote myself a little Qt helper class doing exactly that. But the same means my system communicates with my photovoltaic inverter and the grid smart meter. In this video, we will look at how to interact the EVSE. The EVSE I use offers a wide range of data in holding registers. If you're not familiar with Modbus, this is probably the most frequently used register type besides discrete inputs, coils, and input registers. Think of a memory segment available for you to read and/or write remotely. If you want to interact with a Modbus device, the first step is always to get documentation about the available registers. In the case of my EVSE, it can be downloaded from the manufacturer's website. There's quite a number of different brands of these devices, but the basic concepts are normally the same. For instance, it provides the charging state at address 1000, and it is an unsigned int with 32 bits. This means in practice, it's provided at the address 1000 and 1001, as every single address point provides a 16-bit number. It has the attribute read-only. It cannot be written. There's even information about how to interpret the return number. With that information, we actually have everything we need to write our code to connect to the device. This is the code I use to connect to my EVSE. On the left side, you can see the class ModbusDeviceConnector, which encapsulates our QModbusClient. Depending on whether you use the first or the second constructor, it will either connect via a TCP/IP connection or via serial bus. For a TCP/IP connection, you need to pass the network address and the network port. For a serial connection, you need to pass the serial port name and the different parameters. The constructors create the respective QModbusClient instance, QModbus TCP client or QModbus RTU serial client, and pass the parameters via setConnectionParameter. Then you have to call connectDevice. That's it. If the server is reachable, we should now be connected. Note that there are quite many Modbus servers which only support one incoming connection. So if someone else is already talking to the device, the connection might fail. Before we can use Modbus device connector to actually request values from the device, we need to set a server address. It is used in case there are several instances running on the target server. My implementation automatically initializes it to 1. If you have your own implementation, you need to pass this value to every call to QModbusClient send read request and send write request. On the right side, you can see the class P30 EVSE connector, deriving from Modbus device connector. As you can see, it only supports Modbus over TCP/IP, since this is the only connection my EVSE supports. In the constructor, there's a connection made to the connected change signal, which in turn is triggered by QModbusClient state changed. As soon as the connection is made, it starts collecting the values. You have to actively poll the Modbus device for the registers you want to read. There's no such thing like being notified of changes. A polling interval of 1000 milliseconds is quite commonly used, but this depends on your use case. Now, when asking the device for data, we have to specify the address and the length of the data we want to read. There are cases where you can simply request a big chunk of data covering several values. This is unfortunately not supported by my EVSE, so I have to send a request for each and every value. You can see the address 1000 here on the first call to request holding register values. That was the charging state we have looked at on the manufacturer's documentation in the beginning. As all values we want to read are unsigned integer with 32 bits, we have to request 2 values. That's the second parameter being passed. Now, let's have a look what's actually happening when requesting values. First, we need to form our read request. We create a QModbus data unit. As type, we pass holding registers. Additionally, we need the address and the size of the data we want to read. Since this is a read request, we do not set any data values. We use that QModbus data unit and pass it to QModbusClient send request. Additionally, we pass our server address, which is 1 in our case. Send request works pretty much like QNetwork request and returns a pointer to a QModbus reply. We connect to its finished signal to be notified about the result. Either we get a valid result or not. In each case, we emit a signal, either the received signal or the failed signal. Afterwards, we need to schedule the QModbus reply for deletion. That's the caller's responsibility. Once the caller has been informed about the values received, let's see what will happen with the data. As I said, there's 2 values of data delivered. Each value is an unsigned integer with 16 bits. There's a function read uint32 combining these 2 values into 1 value, a QUint32 in the case of charging state. If the state is different from the known state, we adopt it and emit a signal charging state changed. That's it. The other values below use the same approach. That's all. All values are read from the device. You may have noticed that there's one property which is even writable, max charging current. It is used to, you guess it, set the maximum current the EV is allowed to use from the EVSE. If you take a look at the manufacturer's documentation once more, we can see that they are special registers for writing values. These are holding registers as well, but on different addresses. We do not simply write the value where we read it from, address 1100, but to this register at address 5004. As you can see, it is an unsigned int 16-bit, and it is write only. That means a reading request here would fail. To write the value, we use setHoldingRegister values, pass the address, and a QList of QUIN16 with the values we want to write. It's just one, so let us simply put our value into curly braces and pass it. Since our setter method asks for actual amperes, but the device asks for milliamperes being passed, we multiply the value by 1000. SetHoldingRegister values looks almost as requestHoldingRegister values. We create a QModbus data unit request, pass holding registers as type, and the address. Additionally, we pass the size of the values. After creation, we even set the values. Then we call QModbusClient sendWriteRequest to do the work. Even here, we get a QModbus reply, which is our responsibility to delete afterwards. Now, we know how to use QModbusClient to talk to a device via Modbus. In the beginning, I promised we would even have a short look at how a QModbusServer can be used. Let's see. As a little example, I have implemented 3 different registers: 1008, 1100, and 1110. These can be read and will provide information about charging current to the P30 EVSE connector we did discuss. Like my EVSE, it only supports reading of one value at a time. If you try to read something else, read data will return false, and the client will get an error. Otherwise, we pass our data to QModbus data unit set values. Finally, return true, and the request is done. If we want to allow the client to write registers, we have to implement WriteData. In WriteData, I have implemented the register to set the maximum allowed charging current. Register 5004. Only writing on that address is allowed, and it has to be of length 1. In that case, we adopt the value and return true. It will be returned back to the client once it asks for the register 1100. In every other case, we return false, and the client will receive an error. That is all. Now we have a running Modbus server. In this video, I showed you how to use QModbusClient to talk to a device using the Modbus protocol. We even had a short look how the communication would look like from the device's point of view by looking at QModbusServer. I hope you enjoyed the video. If you have any questions, do not hesitate to ask under the video. If you find it useful, share it with your colleagues and subscribe to our channel to not miss the next video in the series. Hej då!